Okay, so today I'm going to be talking about the joint probability function for x and y. And as you can see, this joint probability function is represented by this table here, where these are the different x's and these are the different y's, right? So you can see this section here represents the probability that x is equal to x of 1 and y is equal to y sub 1, right? This little section here is the probability that x is equal to x of 1 and y is equal to y sub 2. And then so on. This would be the probability that x is equal to x of 1 and y is equal to y sub n. And as you can see, I have a little column here, right? To where this is the probability that x is equal to x of j, where j represents any of these rows here, right? Any of these rows that I choose. And this probability that x is equal to x of 1, so this row here, right? That's going to be the sum of this and this all the way to here, right? So this is equal to the sum from, so this will be I equals 1 to n. So you can see it's going from 1 to n, right? Of the probability that x is equal to x of 1. Notice that x is equal to x of 1 is in all of these. And the y is going to be the one that changes, right? Y is equal to a y sub I, right? Where I is going to be 1, 2, and so on, right? Goes from 1 to n. Okay? So this would be the probability that x is equal to x of 1. And then in general, the probability that x is equal to x of j, right? For any which one I choose, right? For any which one I choose, probability that x is equal to x of j, this is going to be the sum from I equals 1 to n of the probability that x is equal to x of j and y is equal to y sub I, where j is a fixed one, right? And I is representing that index that goes all the way from here to here, right? Where I goes from 1 to n. And j is fixed in this situation, right? So, as you can see, I also have y sub 1 and the probability that y is equal to y sub 1. I have this row here, right? What this row represents is it's the sum of all of these rows here. So I have this row here that represents the sum of these guys here, right? So let me scoot down. So the probability that y is equal to y sub 1, so that's going to be this guy here. That's the sum of this one and this one all the way down to here. So that's the sum from j equals 1 to m, right? Because we have that it's going to be the sum of these guys here, where it's going to go from 1, see x of 1 to x of m. Probability that x is equal to x of j. And notice now the j is the index, right? So the j represents going from 1 to m. And this would be y equals y sub 1, right? And now, for any of them, the probability that y is equal to y sub I, right? So now in this case, the I is fixed, right? For any one of these columns I choose, this is equal to the sum, j equals 1 to m, probability x is equal to x of j, and y is equal to y sub I, right? Where y sub I is any of these I choose. It could be y sub 2 or y sub n, right? Okay, so these are really important for when we want to talk about expected value. All right, so now we're going to be talking about expected value. I'm going to have these two important ones right here with our table. So remember, well, let's talk about expected value of x, right? So remember, the expected value of x was equal to the sum. So in this case, it's going to be from j equals 1 to m, right? Remember that was the j's represent going from 1 to m, right? Of x of j times the probability that x is equal to x of j, right? This was the definition of expected value. But now we know that the probability that x is equal to x of j for any of these we choose is the sum of these guys here, right? So this is equal to, so this will be the sum from j equals 1 to m of x of j times, so instead of this, right, we're going to put the sum from I equals 1 to n of the probability that x is equal to x of j and y is equal to y sub I, right? Because that is the probability that x is equal to x of j. So ultimately, what the expected value of x is it's the sum from j equals 1 to m of the sum of from I equals 1 to n of x of j times the probability that x is equal to x of j and y is equal to y sub I. So literally what we're doing is we're multiplying x sub j, any which one of these we choose, times these probabilities, and we're adding all of these probabilities together, right? So that is the expected value of x. We're doing the sum of this and the sum of this, right? We're multiplying every single one by x of j, whichever one it associates with, right? So that is the expected value of x. The expected value of x is equal to the sum from j equals 1 to m, the sum of I equals 1 to n of x of j times the probability that x is equal to x of j, y is equal to y sub I, right? And the expected value of y is derived the same. The expected value of y, right, is equal to, so by definition, this is the sum from I equals 1 to n of y sub I times the probability that y is equal to y sub I, right? But remember, the probability that y equals y sub I is this guy here. So let me try to get that here. So this is equal to the sum from I equals 1 to n of y sub I. And then here we're going to put, this is the sum from j equals 1 to m, the probability that x is equal to x of j, and y is equal to y sub I, right? So ultimately, this is going to be equal to the sum from I equals 1 to n of the sum from j equals 1 to m of y sub I times the probability that x is equal to x of j, y is equal to y sub I, right? So, let me scoot that here. So we can actually rewrite this in a way to where we know it doesn't matter how we add things together, so I'm going to make it so that way it looks as close to the expected value of x as possible. So I'm just going to move the sums, right? Because we know adding is associative, right? It doesn't matter, or not associative. Well, yeah, associative and commutative, right? So we can arrange these however we want, right? So we know that the expected value of y is equal to the sum from j equals 1 to m of the sum of I equals 1 to n of y sub I times the probability that x is equal to x of j and y is equal to y sub I, where of course it just represents the y sub i's, right, whichever one we choose, times each one of these probabilities individually, the sums of here and the sums of here, right? So this is my expected value of x right here, right? And this would be my expected value of y if we're dealing with a joint probability function.